The computer platform basically seeks certain basic skills to be developed into you. But before we look into the basic skills, what are the basic objectives of this particular program? Well, the basic objectives are defining various components of computer and finding and evaluate the performance, evaluate the computer for a given situation. So a computer is to be designed, a computer is there for a given situation. You have to evaluate whether this is the correct computer, or you should have a lower processor oriented computer, and so on and so forth. Identify various functions of operating system and use of an operating system. Number 3, dealing with computer upgrades, and number 4, dealing with basic issues relating to computer networks. Although this particular session is not aimed at dealing with all these 4 objectives, however, you really have to go through all these things through your course materials, through your PowerPoint presentations, and whatever reference material and website related reference which have been structured or which have been given to you. What are the skills which we are aiming to be developed through this particular course or the first course in the IT program? Well, the basic skills which we expect from you happen to be to identify and correlate concepts and terminology of computer hardware to performance of computer in given situation. So basically identifying various things and correlating various things in a given environment, relating the operating system concepts to an actual operating system and working with an actual operating system. Number 3, identifying upgrade opportunities, and number 4, working with the network operating system and making policies along. Policies such as who is who, what kind of facilities should be given to various kinds of users. So basic performance related objectives have been set up as far as this particular course is concerned. But how to get these objectives fulfilled? The objectives as well as how to get those skills being developed into us. Well, to get it, we have various 3-4 step process which you have to undertake in order to fulfill all the requirements. There need to be a coordinated learning of various learning components. You have multiplicity of learning components, which includes the Gyan Darshan presentation through teleconferencing, the Gyan Darshan video session presentations which are done sometimes in between, the recorded video sessions which are already available at your telelearning centers which are to be viewed by you, and in addition the reference material, the slideshows, the textual material which has been made available to you, and the library facilities, plus some basic information which you need to obtain from internet, from various resources which have been made available to you or which will be made available to you at various telelearning centers. Activities of the day should be explored with all outcomes. Activities of the days has also been prescribed for each day, and you must go through those activities in order to look back whether you have fulfilled a particular day's work or not, how you would like to go further. And they are not sacrosanct that everything is to be stuck on a particular day, although they can be carried forward, but usually they need to be confined within a week. Assignment should be undertaken individually. Individual person should look into the assignment and try to attempt that particular assignment according to the basic criteria for passing and merit and all those kinds of things which must have already been told to you. Finally, references must be explored. Remember, no course in computer science will be complete or can be called complete if you have not gone through the references of that particular course. The information level which is normally obtained from a resource which is normally given to you is to a particular level only. Thereafter, if you really want to go for distinction and other, even higher in pursuits of learning, then you really have to go through the supplementary material, additional material. Even for passing, some basic facts which are given in the reference material should be explored, as this is one particular area of computing which keeps on changing on a very, very frequent basis. But what we are going to do in today's session? In today's session, there are two broad objectives which we will be covering. First, I would like to define to you the basic objectives of a computer system. Okay. And secondly, then we will be discussing about the basic objective relating to the operating system. And these terminology you actually have to relate when you will be working with your computer system. Whatever terminology we are trying to define, we are trying to explore, they will be used when you will be actually working with the computer system. You must understand these in order to efficiently use a computer system. Otherwise, you won't be able to understand what exactly you are doing. And if you don't understand, you won't be able to work with it in on a better form. To begin with, what is the first thing when I face computer should come to my mind? And that is, what is it? That is, what is a computer? Right? So, what is a computer? Computer is a general purpose programmable electronic machine having two principal characteristics. So, it's a programmable machine. What are the characteristics? It responds to a specific set of coded instructions in a well-defined manner. That means responds to a program in a well-defined manner. Number two, it can execute a pre-designed list of instructions termed as program. So basically, both the objectives are pointing to one particular fact. Given a set of instruction, given a predetermined set of instruction, computer has to produce a predetermined outcomes. So basically what we are hinting at, you are giving good inputs to this particular machine, you will get good outputs. If you give wrong inputs, chances are that you will get wrong outputs. In addition, the term in between which is coming called program, if the program is correct, you are going to you are bound to get good results, right results. If that is once again incorrect, you are going to get wrong results. The extent to which your program is correct is the extent to which you will get the results as correct. To what extent it can do various sorts of checkings. Okay. So if this is computer, what should be its components? Well, the basic components of a computer system can be defined into three basic categories. Number one, the main memory of the computer, the central processing unit, and the input-output system. Now, what is the main memory? It is used for storing data and instruction. What is central processing unit used for? It consists of arithmetic logic unit, control unit, and operational registers. And the third unit which a computer system has is input and output system, which is normally operated by control unit. But what are the utilities of all these components? How all these three things are related to each other? Well, I would like to look into the basic components of computer, it basically the three components which we have over there, and how are they related? Well, we can see here there is an arithmetic logic unit, there is a control unit, and there is a main memory. Then we have input-output system. The arithmetic logic unit and the control unit together, along with the number of sets of registers which are being shown in these boxes, constitute the central processing unit. If I have to say about arithmetic logic unit, what it consists of, the arithmetic logic circuits, which are somewhere here, a register called accumulator and a register called MBR, memory buffer register. So these are the two registers which are very much there with the arithmetic logic unit. What this particular control unit consists of? Well, control unit mainly consists of control circuitry, and the job of control circuitry is to generate something called control signal, and these are some of the operational registers which most of the normal computer have. This one is called PC, program counter, which keeps track which is the instruction is getting executed presently. IR is a register called instruction register. The instruction register basically looks in what are the basic instructions which is to be executed by the computer, and this particular register is called memory address register. This particular MAR basically looks into the basic requirements as far as memory addresses are concerned. But what are all these things all about? Well, to define the interrelationship of all these three units and what is an instruction and how its execution takes place, we first need to define some very basic binary terminology. Let us look into those binary terms. What are those? The first binary term is the binary digit. So fondly we know it as bit. BI from the first two digits and T from the third. Okay, so this is binary digit. What is a binary digit? It's nothing but a digit as we see in the language or in the machine form of computers, and it can store either a 0 or a 1. We can equate a bit to something like a bulb, which is either on or off, and that is precisely how in electronics it is represented as, maybe as a high voltage and low voltage or absence of voltage, right? So that is how you represent a bit in computer. That means it is just representing one piece of information, absence of a signal or presence of a signal, and that is either 0 or 1. But all these 0 and 1, simple 0 and 1, can it represent whole sort of instructions, whole sorts of data, and so many other things which we have kept on telling about computer, arithmetic logic circuit and so on and so forth? Well, a bit basically is a very micro unit, and something called byte is a macro unit. We have three things, we have three basic things: byte, ASCII and Unicode. Now all these three are macro units for bit. The purpose of ASCII, byte is basically nothing but a collection of 8 bits commonly used for representing size of file. It can further be clubbed into macros, kilobytes, megabytes. ASCII is nothing but a code, American Standard Code of Information Interchange, which uses, in today's context, 8-bit representation for representing information such as A to Z alphabetic information, numeric information in the form of characters. All that information is represented in 8-bit, and Unicode is an extended representation of information in computer, which is a 16-bit information representation, where all the character set of almost all the languages are represented in computer system. So these are the macro units which are basically used for representing information. If we go further, the next term which we follow in computer is called word, right? Now a word in various computers are defined differently. Sometimes it is defined as the unit of data transfer between the memory and the CPU. Sometimes it is defined as the size of the integer unit in a computer system. So it is a macro unit mainly from the point of view of data transfer. Well, is there any other macro unit? Well, that particular macro unit is numeric data. Numeric data is represented in the form of integer, can be in multiple words, okay, in the form of integer or real numbers. However, all the numeric data in computer will be in the form of binary. Okay. Now numeric data can be integers or real numbers, and both of them can be in the form of binaries. They are commonly fondly known as fixed point numbers and floating point numbers. And finally, what is the most macro term? The instruction. Now what is an instruction in the terminology of computers? Well, an instruction is defined to be a very, very specific thing. Well, an instruction is a binary coded command designed for a specific task, such as arithmetic and logic instructions, looping and decision making, transfer of data and transfer of control. However, I would like to draw your attention to the term binary coded. All instructions are binary coded. The kind of programs you write are high-level language programs. They are transferred to binary form through the process of compilation. So all instructions for a raw computer are in binary form, and all instructions may be of the type of performing an arithmetic operation, logic operation, arithmetic operation all of you understand, logic operation and or functions on binary data, looping and decision making functions, transfer of control and transfer of data. Now these are the two terms which we would like to explore further, but not at very moment. We would like to know some more details about the computer structure, and then we would like to explore this particular terminology further. Well, if I want to know about some of the more structure of the computer, what is the first concept I have to talk about? I have talked about the basic concepts, the basic minimum terminologies. But now let us talk about something called an architecture of the computer, which was defined by von Neumann, and we would like to focus on key features of it, just the key features. What is the first key feature in that particular category? Sequential execution of instruction unless explicitly modified by an instruction. What do we mean to say? Instructions are executed sequentially, and transfer of control instructions are the one which will attempt to modify the sequence of an instruction. Very important thing to understand. Okay. So once again I am repeating this particular concept. Instructions are executed sequentially unless they are modified, the sequence is modified by sequence control instruction, that is control of sequence instructions, or some sort of if then else or loop termination instructions. Okay. The second key concept here is data and instructions are stored in a single read-write main memory. Right? Now this is very important concept. Now how do I like to define this particular concept? Well, let us try to visualize this in the form of graphics. data is stored and instructions are stored in the one single memory, which is in the form of a large linear array. So somewhere over here you are visualizing instructions, somewhere here is the data. Now there are two questions. How the instruction will go to the control unit in order to be interpreted, and execution should take place over there, and how the data will be moving from this particular place to this particular place where the arithmetic operation is performed under the control of the various instruction, which basically infers what is the kind of operation to be performed, whether it is addition, subtraction, or what operation is to be performed onto the data which will be coming to this particular thing. So if you remember, what we talked about was control of data instruction. So control of data instruction will primarily look at this particular aspect, transfer of data from the memory to the central processing or arithmetic logic unit. Right. Is there any other typical thing before we start once again detailing about this, the instruction execution paradigm? Yes, there is one more aspect which have to be looked into, that is the contents of the memory addressable by location. The contents of the memory are addressable by location irrespective of type of data stored, and the main memory is also called random access memory. What do I mean by saying these two terms? Once again, the data is being stored into the random access memory over here, or the main memory over here. So this is also called random access. Why it is called random access? This particular register called memory address register issues whatever address we are basically talking about. Okay, and all of those addresses, any one of those addresses can be recorded in memory address register. It is same as saying you have a big apartment over here, and in each apartment you have a unique flat number. So each flat has different address, and that address is inferred or interpreted or indicated by memory address register. Okay, so that is what we mean to say, all these terminology, right? Now how an execution of instruction takes place. Now that is where we should come to. Now if I want to execute an instruction, what should be the first step? Obviously the instruction is to be fetched. So what should be the first step for instruction execution? Get the instruction, right? Now if I would like to see where exactly the instruction is residing, somewhere here, and that instruction is to be brought, there is a link to MBR, and from there it is to be brought to somewhere in the control unit. Okay, so instructions are brought. How they will be brought? Computer doesn't know initially whether it is an instruction or data. For it, it is just some data which is stored into the main memory. However, it is the program counter which tells, yes, this may be the instruction. So it is brought to the memory over here to MBR, and it is taken to the instruction register. Okay, now that is fetching the instruction, get the instruction. The second step over there is decode the instruction. Now decode the instruction will be once again somewhere here, instruction register. The job of instruction register is to give that particular instruction or furnish that instruction to control circuit, and control circuit in turn will understand which instruction we are talking about by generating necessary control signals, and those control signals will be for arithmetic, maybe for arithmetic logic unit, maybe for fetching more information from here, or maybe for some input and output. what is the third step? Get the operands, right? So the control signals are basically trying to tell us, get the operand, where exactly the operands are residing. The data. The data is residing in the memory itself. So what is the next objective? To get that data into the memory buffer register, or maybe bring some data to the accumulator, load the data into it, right? Sorry. Get the operand, perform the desired operation then. Where exactly this desired operation will be performed? It will be performed in the arithmetic logic circuits, right? So the required operation will be performed over here. Where exactly data will be brought? In the memory buffer register, or maybe to accumulator register, right? Maybe from input-output system to these two places, but the instruction will be ultimately the operation, which is basically it is referring to, may be performed in this particular place. Most likely, if it is an arithmetic logic operation. If it is any other operation, then probably some other step may be followed by this control unit by itself, and those operations will be automatically taken place. Okay, and finally communicate the results back. Where exactly these results will be returned back? All these results will be returned back to the main memory, where exactly the position for the results are to be stored. So in nutshell, what is the instruction execution now? Get the instruction, get the operand, operate upon whatever data is, and store back the results back to the main memory. And that's how instruction execution takes place in a computer system. But one thing which we are focusing all the time, all that information has to be in the memory. After all, what is the need of memory? Why can't those instructions be directly brought from input-output devices? And why they should be placed in the memory first, and then execution has to take place? Well, there are various reasons for this particular thing, and those are non-linear programming paradigm. You are dealing with situation when you are jumping from one instruction to another. If all those instructions are already there in the main memory, it is easier to take jumps. An operation on data may require more than one data value in a predetermined sequence. So if you directly bring all those things from input-output, probably you will keep on entering that information for quite some time. Okay, speed of input or input-output devices, in fact, versus the speed of processing unit. Okay, they have input-output devices are very, very slow in comparison to speed of processor, which is measured in terms of nanoseconds. Okay, memory is much faster. Speed of devices such as keyboard, you may take several milliseconds to press a key, and that is one of the reasons why you need to have memory in a particular system. However, how large memory you would like to have in a system? Well, a large memory capacity is desired with low access time. Two extremes which we are having. That means employ memory hierarchy. What do we mean by low access time? Low access time probably is referring to as we are moving from fast electronic memory to slower magnetic memory. What do we mean by saying so? Well, let's look into the graphics for that. Registers are the fastest. They are within the CPU. Cache. We would like to talk about this particular memory a bit. Main memory. We have always talked about, okay, so here is a main memory which contains all the data. But probably main memory is somewhat slower than the CPU registers, and that is why we need some intermediate memory called cache in between the two. Magnetic disk. all these memories, top three memories, are volatile in nature. You must have experienced this particular fact. As soon as computer is switched off, your program which you were processing is normally loses its content, it's wiped off, or the editing which you were doing is gone. Okay, that is why these three are volatile. Next, disk cache. Probably this is intermediate between the main memory and the magnetic disk because of the speed differences between the two. And finally, we have magnetic tape and optical disk. Sometimes we can club it along with magnetic disks, although magnetic disks are faster. So we can show a link directly to disk cache and main memory through this. Okay, but this is something which we always try to have as backup storage in our computer system. These are normally the online storage in our computer, online readily available. And this cache try to make the whole process very, very fast. So this is the basic idea of memory hierarchy. But what are the characteristics as we are going down the line in the memory hierarchy? Well, as we are going down, it decreases cost per bit. It increases the memory capacity as we are going down. It increases access time. The time to access a bit of information increases. It decreases frequency of access of memory by the CPU. Decreases. So most of the accesses must be from the cache memory. Thereafter, cache is in between main memory and the processor. Earlier cache was not there. Now cache has been made just to fasten the pace of the computer or increase the performance of a particular computer system. So these are some of the common traits as you go across the memory hierarchy of a computer. But why this particular memory hierarchy works? What is the advantage of this particular memory hierarchy? Why should I assume that this particular memory hierarchy will work and will give me good results? After all the data is to be fetched ultimately from the main memory. But what is the importance of this particular memory hierarchy? Well, the programs which are there in the secondary memory are to be brought into the main memory. Once they are into the main memory, only thereafter the processing through cache may increase the performance. Why that increases the performance? Well, there is a locality of reference. What is locality of reference? During program execution, memory references by processor for both instruction and data tend to cluster in specific area. And the main reasons for this particular clustering happens to be there are iterative loops in the program, there are subroutines, functions in programs, and use of data structures such as array in data. So you will find most of the information is cluttered in specific areas. And because of that, if I just put a portion of that particular information from main memory to the cache, the response may be faster, because the information now can be cut from the cache. Remember, cache is almost 5 to 6 times faster than main memory. However, all the information should be in the main memory before the processing can take place. There is an antithesis to this particular concept. You will be reading that particular thing in virtual memory concept, but that will be coming at a very later stage. To go into more deep into the RAM, what are the basic RAM technologies which are existing in the present-day computer? Well, there are two basic RAM technologies: dynamic RAM, DRAM, which store data as charge capacitor, and this requires periodic refreshing. In fact, this is what DRAM is, what your normal main memory is constituting of. And this DRAM basically is slower because it requires some sort of refreshing, and they are charge capacitor. This is a slower technology. On the other hand, you have static RAM, which are traditional flip-flop, same technology which is made which makes your processor logic gates and doesn't require processing. So what is the advantage of this particular thing, or how would we like to compare SRAM with DRAM? Well, DRAM is supposed to be more dense, less expensive, but require circuitry for refreshing. DRAMs are slower than SRAMs, so for large memories they are preferred. That means all main memories are to be made from DRAMs, which are 5 to 10 times slower than SRAMs, and cache memories are made of SRAMs. So this is how you make smaller cache memory. Okay, you make those smaller cache memory from SRAM. Your cost is limited, yet it is performing a very good job with the help in conjunction of locality of reference and your main memory. It is doing a fantastic job as far as increasing the performance of computer is concerned, and that is the key aspect. So let us look into what is cache then. It is built from SRAM technology. Level 1 cache, L1 cache, is built into microprocessors of today, and level 2 cache is normally external to microprocessors. And you will find most of the motherboards are equipped with level 2 cache, and today's microprocessors, Pentium and all that, have a minimum level of L1 caches with them. We talking about caches, so let's talk about a bit of disk cache also. What is disk cache? Well, disk caches are used to speed up access to data on a disk. A portion of RAM called soft disk cache that can be utilized as disk cache, or a RAM as part of hard disk cache. However, this is more expensive kind of process, and normally what is the objective of these disk cache? To access the information from the secondary storage input-output devices to the main memory of the computer at a fastest rate. Coming back to the central processing unit, the memory, and the input-output device technologies or techniques. How are they connected with each other? After all, they are communicating with each other. The diagram which we had, they were just connected through some lines. But how in practice they are connected? Well, for that you require something called interconnection structures, right? So what is an interconnection structure? It is a collection of parts connecting various modules such as memory, input-output, and CPU. Most common interconnection structure is what is called bus interconnection structure and multiple bus interconnection structure. I think this particular terminology will be put across you many a times, that what is bus. So let's look into what is bus interconnection structure, right? Bus is a shared transmission medium. It has only one module transmitting. I mean, this particular is a requirement. Only one module transmits at a time, thus require arbitration. Multiple lines, pathways, each transmitting one bit. A bus that connects CPU, memory, and input-output device, or input-output system rather than device, is called system bus. So once again, what is the requirement of the bus? Just to make various communication possible across these entities. Okay, and how they are transmitted? Through various lines. If you have seen your motherboard, you will find various thin copper wires. That is bus lines. Okay, so try to visualize that at some place. What is a system bus then? Let's look into slightly more detail. Typically 50 to 100 separate lines. Each line may be assigned a particular meaning. 3 functional group of bus lines. These are data lines, address lines, and control lines. Data, address, control. address belongs to memory. Data between memory as well as the processor register, that transfer. And control to control various devices such as input-output devices such as memory. Few lines are also used for power distribution. Definitely bus is powered, and bus may be dedicated or multiplexed. It can be used only for one of these three purposes or maybe two of these purposes, of course one at a time only. So multiplexing is basically trying to bring some sort of reusage in the bus. So less number of lines can be used for greater purposes. However, at the behest or at the cost of that there may be slightly more cycles required for processing of information in that particular case. So in a nutshell, this is what basic configuration of a computer system is, right? But in all that configuration, we kept on emphasizing one particular term, the performance. So what is the performance of a computer? Well, performance is the ability to execute instructions in accordance to the specified configuration capabilities. You may have a very high configuration of computer, okay, yet that particular configuration is not able to solve your problem because some of the things are not made conversant or made, let's say, what we use the term, conversant with each other or maybe consistent with each other. If that is so, then you are bound to face efficiency related problems. So how do you measure various, or how do you measure performance of a computer? Some measures are utilized for processor. Some of the CPU speed terminology such as million instruction per second, megahertz are the measures of that. The memory, how fast the memory is in terms of transferring information. The bus, how fast the bus is. You must have heard the term in context of motherboard, 100 megahertz, 133 megahertz, the bus speed. Storage technology, how fast it can transmit information between various storage units and the bus or the processor in that context. And the overall system. Many a times people suggest that you should go for branded products and not some of the manufactured or maybe simple products or assembled product. If you have gone to branded product, normally the efficiency of a branded product, that all the devices are well in tune with each other. So performance of overall system, despite having a lower performance, may be better than some assembled product. I'm not saying that all assembled product may be done, because it really depends on whom you are approaching for this kind of an assembly and how much he or she understands this particular concept. If you are doing that particular assembly, you must understand these concepts and you must try to look into this particular aspect. So what we have covered by now, we have just covered the basic computer system, what are its components and what are the issues we should basically focus when we are dealing with a computer system, especially its hardware issues. Now let us try to look into some of the operating system or operating term systems. Now let us try to look into the definition of an operating system. But before we go to the definition, the first question we always ask ourselves, why study operating system? Well, we must study operating system to interact with the hardware for performing various tasks, to understand inner functioning of computers and getting the inside concept of and techniques which may find general applicability. Not only we will be able to use a computer efficiently, but the concepts obtained from the knowledge of operating systems, slightly deeper, not the working knowledge, you will be able to do many a programming problem solutions by just applying the knowledge which you have obtained from operating system concept. So we are giving you quite a detailed information in this particular course. Quite information has been passed on to you about the operating system. But what is an operating system? That is the first objective to understand. It's a large software, and what does it do? It manages processor, memory, file system, and definitely input-output devices. So everything. So the rudimentary level of operation is the control unit, and the operating system basically tries to govern, manage all those resources. The task will be done still by the control unit and the central processing unit, but operating system will govern the overall performance of the system or efficiency of the system, how it works. Let's look into some more details. What is an operating system? It keeps track of status of each resource and decides about which process have control of resources. Other programs use the facilities provided by operating system to gain access to resources. So here is a program which is trying to make computer somewhat friendlier for you. Some of the simpler tasks can be done in a simple way, such as in Windows 95, a GUI based operating system. You can do many a task simply copying of a file. Okay, if you really have to write a machine code for it, probably it is too difficult for that. Okay, but how do you interact or communicate with an operating system? Well, communication with operating system can be by two things: system calls, okay, and if other programs are doing it, then they do it through system calls. And operating system commands by the users, they include, if you are talking about operating system commands, they also basically, we can say, graphical user interfaces also can be clubbed at this particular level of interaction. But we are focused at one of the major problems with operating system, and that is how to increase the efficiency of resource utilization of a computer system. What you will find in computer system, if I am just working with one task, the resource utilization in computer is very, very poor. If that is so, what is the alternate? Probably we move on to from one person to maybe something called multi-programming kind of environment. Now, what is multi-programming? It allows multiple processes, programs at the same time. Multiple programs to be executed in a computer at the same time. Well, that seems very, very fascinating. But I'm dealing with a personal computer. So what can I do on a personal computer? Well, on a personal computer, I can follow a step called multitasking. Well, multitasking supports concurrent execution of two or more active processes. It maintains code and data of several processes in memory simultaneously. Okay, so multiple processes. You might have initiated multiple tasks and all of them are in the memory, and multiplexes processor and input-output devices among them. It supports memory protection facility for resident processes. All those processes should not get mixed up. They should have their own memory. They should have their own processing space. They should have their own processing requirements being fulfilled. That is what multi-programming will look into. More? Yes. Multitasking is one of the mechanisms that multi-programming system employs in managing the totality of computer system resources, including processor, memory, and I/O devices. So this multitasking actually is a part of multi-programming. And multitasking operation without multi-user support can be found in some advanced personal computer. And in fact, you have found them in whatever computers you are using. They are quite advanced computers, if we want to say that way. Even Pentium system is quite an advanced computer, if we want to compare it with any older system. Okay. Now, let us look into slightly more details of multiprogramming. What do we mean by multiprogramming then? In addition to multitasking, multiprogramming supports sophisticated memory protection. Among various processes, it allows sharing of information, which normally multitasking does not do. It enforces concurrency control for shared input-output devices and files. Basically, this is somewhat you will be reading in your third year of BIT program, these kinds of things. It supports multiple users, that is called multi-user operating system. Multiprogramming implies multitasking. However, multitasking does not imply multiprogramming. So, the other way around, this kind of a statement may not be correct. Let's look into some more operating systems from the basis point of view, because these are the two. Others may also be utilized for some more purposes in computers. One is multi-user operating system, and that provides facility for maintenance of individual user environment. Okay? So wherever you will find mainframes, you will find this kind of a thing. User authentication for security and protection, passwords, okay, and your accounts, account names, they will be provided. Per user resource usage accounting. How much you have utilized a particular computer can be clubbed. Some today's modern distributed or systems, I mean, we won't call it a distributed operating system, but network operating system like NT and Unix, all these have all these facility of multi-user operating system, which we have seen. Then we have multi-access operating systems. What is multi-access operating system? Simultaneous access to computer from more than one terminals, does not imply multi-programming necessarily. Example is transaction processing system having many terminals under the control of single program. To certain extent, railway reservation system can be categorized under this kind of a category. So multi-access systems. Is there any other category? Yes. We have multi-processing or multi-process operating system. They manages operation of computers having multiprocessors, or multitasking by definition as execute multiple tasks on different processors. Multitasking feature may or may not be allowed on a single processor and may be time sharing or real time. Now what we are introducing here are two more terms, real timing and time sharing. We need to have some more details about what is real timing and what is time sharing. So let's look into what is time sharing. Time sharing is a popular representative of multi-programmed, multi-user operating system used in many large CAD and text processing systems that belong to this category. What is the objective? Good response time, often attempts for equitable sharing of common resources. And most common resources of those common resources is central processing unit. So multitasking, the time sharing system will distribute a minimum small quantum of time of processor to all the processes, and everybody feels, oh, my job is being processed, but that's not so. Everybody is getting processor with some time share. What is the real-time systems then? Well, the real-time system is used in environments with large number of external events to be processed in a short time. Examples are industrial control, telephone, switching equipment, flight control, military application, and the primary objective in this particular case is not resource utilization, but quick event response time. Resources concern is secondary. Why we have this kind of a thing? The objective is very, very simple here. They are very critical system. If there is a failure in some of the process, it is to be responded to immediately. Otherwise, there will be more problems. So resource utilization is secondary. So with this, what we have covered is basically some basic aspects or relating to various operating systems, which can exist in computer systems of today. And what is the prime objective of any of those type of operating system? Primarily to enhance the resource utilization. Okay? But if that is so, there must be another prime objective, that we have our operating system as resource manager, right? So what do we call an operating system? The resource manager. And what are the requirements of an operating system as a resource manager? Although there may be 4 requirements, the 4 resources it manages, I have tried to present them into 3 basic categories. Well, the very first, what is the prime resource? The processor. So operating system as a resource manager should do what? Processor scheduling, right? Now what is that processor scheduling? Processor scheduling is set of policies and mechanisms supported by operating system that controls the order in which work to be done. Multiple programs are there. Out of those, that particular resource called central processing unit is to be given. And how it can be given? The scheduling of CPU among various processes is to be done. And what is that particular job being done by the operating system? Who does it? A scheduler does that particular job. And operating system acts as a scheduler. It selects the next job to be created, and the aim is basically the scheduler aims to maximize CPU utilization, performance, throughput, and minimize the turnaround time, that is the job submitted and responded to, the response time, the time a CPU takes to response to my program, and waiting time. The waiting time is how much time your program has to wait for getting the CPU. So scheduler is doing that particular job. And where exactly scheduler is? Operating system. The second key task or key thing which one operating system has to do is memory management, right? Now, in the memory management, what it has to do? It is mainly concerned with allocating physical memory of finite capacity to requesting processes. Many processes are there. Your memory capacity is fixed. For example, if you are talking about personal computer, it has 128 MB memory. Okay, that is to be allocated among various processes which you have started. No process can be activated before the finite amount of memory is allocated to it. That is because of von Neumann architecture principles. 2 conflicting requirements are separation of address space and sharing of memory. Okay, so these are 2 basic requirements of any memory management system. The third category which we have divided is file management, and device management to certain extent is clubbed into it. The file management hides all device specific aspects from the user, maps file access requests from logical to physical file space, transmit files between main and secondary storage. This is where you will find, this is most important for you. It is doing a job which basically is, you have asked for a particular file and that is being made accessible or being made available to you. Finally, file management manages secondary storage such as status, allocation and deallocation. secondary store, okay, support for protection and sharing of files, and recovery and restoration of file after system crash. So basically some of the tasks of device management can also be clubbed into this particular category. However, what we have looked into the three basic aspects. The first, we tried to visualize what an operating system is and why should we study operating system. Secondly, we looked into various forms of operating system and their objective. And third, we looked into operating system as resource manager. With this, we end this particular session. Bye for now.